This is Jeff Ryle from G4 Geomatic Resources in Stafford, Texas, and today we're going to go over the one-step field transformation. We're going to jump into a little bit more detail than the quick tips, and so let's get started. Just to briefly introduce it, in this example, we did use Smartnet on the network. We could also use a base rover setup, point-to-point with a radio. Some clients, if they do that, they might want to set up on one of the control points. You don't have to. You can set the base up in any location that is wide open, safe. But if you want to set up on one of the control points, that would work as well. The advantage of doing the one step is we can transform or shift, rotate, and scale directly into the local coordinate system. This has advantages and disadvantages because we can, first of all, check the integrity of the existing control on site to make sure it's okay by looking at the residuals. If there's a bad point that's off, it'll be flagged, and we'll go over this in the video. And if that local coordinate system was in surface or ground, then we transfer it directly into it. And once again, this can then be transferred into Infinity to be looked at as well. And that coordinate system defined on the controller will be transferred from to USB to other controllers in the field as well. Once again, we recommend at least 4 points. It's nice to have a fifth point as a redundant checkpoint. And the 4 points that goes redundancy, you want to make sure that these surround the work area and work within inside these 4 points. You can use more points if that's okay, but we recommend a minimum of 4 points, and a fifth one is a check. The one step is for smaller areas, typically 3 miles by 3 miles or 5K by 5K. And once again, we want the 4 points to surround the job area, work within those parameters, and a fifth point as a checkpoint. Once again, we call it the one step. It could be called a calibration or a localization. So if I had 1 point, we have we shoot it in. There's really not much going on here geometrically. And what we're going to do is we're going to show in the video, we can start and hit 2 known points. This would then shift us over in this local orientation. And there's no redundancy, but this would then also transform us into that local coordinate system. And a 2 point is really like a baseline. Geometrically, it's not that solid, but it'd be a really great technique for us to use this as a starting transformation to find some other points on that job site. Especially if it's a larger tract of land, we can then rotate in and start looking for those other control points that save a lot of time. All right, let's just fire up the video here. Okay, so what we do is we have the CS20 here, and we had a job called Craven's Control. So if we click on there, we imported the data. So if we go down to import data, ASCII file, once again, it'll say, where do you want to import it from? In this case, better USB. We don't have USB plugged in. That will pop up. And the example says point number, north and eastern height. If you need to change that, hit function, F1 settings, and then you can define the order. Right now it's north and eastern, but if it's east and northern, you can change it there. So we imported the local control points. We created a job called Craven's Field 625. And we actually, just to speed things up, we've shot points in. So we actually edited the points. If I click over and hit mean, it's really important. We took 4 shots on each point to average it. And also we want to make sure that if we're checking someone else's control, we can look at the splits and make sure that our RTK is good. So you can see here, the delta position and height is within 4 or 5 hundredths. And so once again, the points that we're using, we shot multiple times with the GPS. And as we said in the previous video, where you can use that application create coordinate system, which is the one step. And once again, we're trying to shoot RTK points in with GS18 points or latitude and longitude and assign them, pair them up with the local north and eastern to create a transformation. So once again, we'll do the one step. We'll hit OK and it asks for the name. So we can just type in the name that we're going to use. In this case, we'll do 625. And here we're going to define where the jobs are. So once again, the WS84 is our RTK points. We shot in the Craven's field. And the local points that we uploaded were under Craven's control. All right. So once this is set up, we have the name. We can hit OK. And we'll change the height mode to orthometric. And we'll use a geodal model. If you call the points the same name, the F6 auto will automatically line up those points for us. Okay. But we can actually hit new and then line up and go pick point number 1 and manually pick those points. So what we want to do is pick 2 points, and these points number 1 and 2 are the 2 points that we're going to use in position and height. So we'll hit OK and we'll match them up, and take a look here. There's no residuals. So once again, we're just trying to rotate into that system, and that would then shift and rotate into that local system. And with no residuals, this is not the best geometry, but what we're trying to do is we'll hit OK, and we're going to store this, and this will then update our coordinate system to allow us to get on that local system, and we're going to use this to then go and try to find the next points. So once again, if we went back to stake points, we can then pick the points, and what we want to do now is from where we're at, we type in the next control point or boundary point that we're trying to find. In this case, it's boundary point number 3. And now it's guiding us from north where to go. So we could zoom into that point, or if we hit the I button, and you can pick whichever way you want to stake out. So in this case, it's to north. If we hit the third one up, that's the course made good. And that would give us, saying when we start walking, that arrow will update. We could go 99 feet to find that point. What we then do is go navigate to point number 3, probably gets within a couple tenths, shoot that in. Then we'll go to the 1 step. Instead of doing 1 step again, we'll say modify existing. And we're now going to update our 1 step. And there it is there. We call it 625.25. And once again, all this stuff remains the same, and it holds the previous settings. And now we'll match up point number 3 with point number 3 in the local point. So hit F2 new, position height. Never hit calculate. Look at the residuals now. So once again, the vertical, because it's a plane and there's only 3 points, there's no redundancy. But these 3 points agree very well. They're all within a few hundreds. 400s is the worst residual. And what's going to be updated, so now 3 points. Okay. So that's looking good. Once again, we'll just double check those residuals, and we'll then hit the OK button to accept that. And now we've got a better geometric. And once again, before it stores it, we can look at the larger residuals, and there's the northern is 300s, eastern's 400s, and height is smack on because there's no redundancy. Once again, we could tab over, and now that's updated automatically. So we can go back to stakeout, and now we want to stake out and find the 4th point. Okay. So what we'll do is I'll just minimize this real fast. So in this case, we hit the 2 points. We stored that 1 step. There's no residuals. And once again, we picked number 1 and number 2. And then, as we said in the previous video, we highlighted point number 3 and started navigating and shot that point in. So after point number 3, we've added 3 points to modify that 1 step, and then we can stake out point number 4. So the goal here is to hit these 4 points, and we have a bunch of points we need to stake out within here. This is a smaller project, but it's just an example. So once again, on your job site, be a lot bigger. Okay, so let's go back to the video, and we'll navigate to point number 4. And once again, there's our course made good. We'll navigate, take 3 or 4 independent shots on that point to update it. And then we'll go back to create coordinate system. Once again, we'll click on it, arrow down to modify existing, hit OK. And we did 625. All this stuff looks good. We'll hit F2 new, and then we'll match up 4 with point number 4. Let's type it in. And that's the control point. Position height, we'll hit OK. And then we'll calculate. So once again, the residuals look great. Now we've got redundancy in our vertical because they have 4 points. Okay. All those points. What we're going to do now is I'm going to show you if we did have a point, and let's say there's 2 rods out there that we came across. Let's put that other point that's bad, and I'll show you how the residuals will change. So we came in here, and the local point will come to pick this control point number 2 bad. Hit OK. And now we'll hit calculate. And now what I want you to take a look at is, see, it's highlighted. Number 2 has the highest residual. Okay, the vertical looks good, but it's saying a residual of 0.39 of a foot in eastern, 0.33 of a foot in northern. But look at the other residuals, they are high as well. Okay, and it's spreading that error through all the points. It's flagging number 2 as the one it feels most likely is bad. It doesn't mean the other points are bad. Okay, so once again, we're checking our control points. There's a problem with this control point. Okay, we're looking at the residuals. Number 4 looks good, but number 3 and number 1 look pretty bad as well. But the error is being spread through the transformation. So what we'll do now is hit the OK button. We can go back and we'll just re-edit that. Or if we hit the match, we can just take that out. And those 3 points, let me just back up a second here. Okay. So once again, those residuals don't look good. So we'll come down here, we can highlight point number 2, and the match button, we can click on this button here to change that to none, just to ensure the other points are good. So we'll toggle that, match is none, hit calculate, and here we check all those 3 points. And those 3 sets of residuals look really good, and that builds my confidence that these points number 1, 3, and 4 are good. There's 2 rods we found at point number 2. What we need to do is go in and put that second rod back in, because we isolated which rod is bad. So this is a really neat feature of the one step. So we'll come back up, we'll edit that, we'll change that local point back to point number 2, and now we can change our match back to position and height, then hit OK. We'll recalculate, and once again, our residuals look really, really good. So that's a neat way to identify control points. Find out if they're good or bad in real time, even before you start the project, which is a really powerful feature. Okay. All right, we'll page over at the end to coordinate system. We'll spread the residuals. So hit this tab to 1 over distance squared or multi-quadratic. It doesn't make a huge difference, but it's just another way to spread any error relative to your distance from that point. Okay, and then we'll store that once that's now stored. If we go back to our job, like we said earlier, we're now fixed. We're now in that local coordinate system. Okay. If I go to stake points, we go to our check shot. So it's good to have a 5th point that we're going to check into. And we'll hit the button. We'll check into point number, control point number 7. And we'll select that control point. Okay. And now we're checking within a few hundreds horizontal. We have a little bit of issue with our verticals, 0.2 of a foot, but that's our check shot. And now we've now performed the one step, check the control points, and we're now ready to go back into stake out and start staking those points out. So we just want to show you how to do a 2-point. This will help us find those other points. Then we can modify, update those other points in real time. Check the residuals. We had a bad point. The residuals reflected it. We took it out to isolate which points are good and which points are bad. Okay. All right. So once again, we did 3 points, 3-point plane. There's no residuals. And the final goal is to hit the 4 control points around our job area to tighten up our control. And there we go. So we shot all 4 points in. And like in the previous video, we showed 1 point that was bad and how to isolate which point's bad and which point's good. We had a check shot is over here, point number 7. It's kind of outside. We typically want to keep those points within our work area. If you're slightly outside, it's not the end of the world. Okay. So once again, those 4 common points gives us, we'll shift rotate. We're basically warping right into those local control points to match the control that's on the ground. That's why it's so critical to check those residuals. Okay. And as we talked about, we really want 4 points, a check shot. We want to spread them out. Having points in a straight line is a poor geometric. That'll affect the accuracy. So yeah, and that pretty well concludes the one step. Take a quick look. If I come to infinity, so these are the points. Right now we're in we're in state plane, I can come down and change it to that local coordinate system that we did, and see how it rotated? Because the local coordinate system, the north was facing up towards the building. Okay, so I change it back to state plane. True north is really up here, and the local coordinate system. So if I came down here and took a look here at our points, there's our points in state plane. Okay, what we'll do now is when we come back here and change our coordinate system to the one step, once again, we open up, we're now in our local northern eastern, and once again, it's now rotated into that orientation because that local system had north up, along, parallel with the fence corner here. So that's a quick overview of a one step. We'd always recommend to download that into Infinity. And once again, this is our G4 team in Stafford, and all our contact information. If you have any assistance, please reach out to us. Hope you found this video helpful and beneficial, and thanks again for watching.